Hi, dear students. Today we are going to solve the physics paper, which is May-June 2024, P21. And our first question is really very easy. It's just giving us, they are just checking the concept of scalar and vector quantities in us. And you know that the concept of scalar and vector quantities is very easy. And the scalar quantities are the ones which are not depending on the direction. They only depends upon the magnitude. But when we are talking about the vector quantities, they are depending upon the magnitude plus the direction, right? So if you will take a look on the first option, A option, that is mass and energy. And both of the quantities, they are not depending upon the direction. They are independent of it. And similarly here, under the heading of vector quantities, in the first row, in first option, weight and acceleration is given to us, and both of them are direction dependent. So these two are vector quantities and these two are scalar quantities. And this is what the requirement of this question is, right? Now we're moving toward the question number 2. They are saying that which name is given to the quantity of matter in an object. You know, by definition, if we will define all these quantities separately, uh, you will figure out that this is the definition of mass. Mass is the amount of matter in an object. So B option in question number 2 is correct. Moving toward question number 3 now, they are saying a body is moved from place X to place Y, where the gravitational field strength is different. This word here is very important. Gravitational field strength is different. What happens to its mass and what happens to its weight due to this move? You know, we know this thing very well that mass remains same everywhere. There is no change whether you are going on moon, on any other planet, on Jupiter, anywhere. So the mass does not change. So it means that from C and D we have to select because the mass remains the same. So we can exclude A and B options very easily, right? Moving toward the weight, as weight changes from place to place, according to the definition, or by definition you can say, or with the help of this formula mg, you know, gravitational field strength will change from place to place, right? So if the value of g remains, it keeps on changing. So when you are taking the product with the mass, the weight keeps on changing. So according to this concept, our C option will be the correct one, right? Now next question. The mass of an object is 2.5 kg. The mass of an object is 2.5 kg. The volume of the object is 480 centimeter cube. What is the density of the object? If you will take a look on the units are in grams per centimeter cube. Here we have like the volume is in centimeter cube, but the mass is in kilograms. So we need to change this mass into grams first of all to see that which like to get our answer, right? So this is the mass and this is the volume, but first of all we need to convert the mass into grams. So how to change that? You can multiply 2.5 with 1000 to get your answer, and this is 2500 grams, right? This is our mass. So according to, when we are going to find the density, the formula for density is mass per unit volume. So mass is 2500 and volume is 480, right? So your answer is, we will check this, it's almost 5.2 grams per centimeter cube. So your B option in it is correct. Okay, let me write the answer here as well. It's 5.2 grams per centimeter cube. Moving on to the next question. question number 5. It states that there are 4 objects. Each have 2 forces acting on them. Like these are A, B, C, and D. And on every one of them, there are 2 forces acting on it. And they want that you will tell which object is in equilibrium. It's very easy. There are 2 conditions for an object to be in equilibrium. Number 1, that the forces acting on an object should be equal to 0. Like the sum of the forces acting on an object should be equal to 0. And the second condition is that there should be no movement. Okay, like sum of clockwise movement and sum of anti-clockwise movement should be equals to 0. So if you will see with C and D option, you will notice that the direction of these 2 forces are the same. So when you are going to solve them up, the sum of the forces is not 0. Like the resultant will be 1 plus 1 here because of the direction is same, and here also these 2 are acting in the same direction, so the resultant will be 2 Newton towards the side, and in this case it's towards the right side. Okay, so we can not include these 2 options in our answer, so definitely it will be from A and B. Now when we will check the sum of the forces in A and B, in both of the cases we are getting the result in 0, but it's difficult for us to understand that which option will be the best one. As we know, there are second condition also with us, that the sum of clockwise and anti-clockwise movement should be equal to 0. So when you will apply that condition on B option, that you will not get the resultant good, it will be crossed out. Why? Because here there are moments which are produced here, and both of the moments are clockwise. There's no anti-clockwise moment to cancel out it. So the resultant moment here will be there. Like there will be some answer in this case. So the object will not be in equilibrium, so it will start rotating in clockwise direction. So we have A option. So A option is the best option to represent that this object is in equilibrium, right? Now question number 6 is here. A ball of mass M falls vertically and hits a hard surface. Like let us draw a diagram here, that this is the surface. Okay, this is actually, here we have a very hard surface and the ball is dropping down from top towards the bottom. They are saying that if the ball of mass M vertically and hits the hard surface, its speed on hitting the surface will be v1, but when it rebounds its speed will be v2, right? So what is the change in momentum? Actually, you know, the formula for the change in momentum is that final momentum minus initial momentum, right? So in this case, mostly the student will tick this answer, D option. But you know why this is not an answer? Actually, the direction of these 2 velocities are opposite. So because of this change, we know, you know, change in momentum is, as I'm telling you, final momentum minus initial momentum, mv2 minus mv1 should be there. But you know, because of the change in momentum, change in the direction of velocity, we need to put the negative sign here as well. So mv2 plus mv1, right? Or you can say that you can take it common, so v1 plus v2 will be the best option. Next, so C option is the correct answer, not the D one. The next question, 7. A stone is dropped from a tall tower and falls a distance of 50 meters. So what data we have? Initially, we have 50-meter distance, and a stone has a mass of 3 kilograms, right? At which speed does the stone hit the ground? So we need to figure out the answer for it. It's very easy. Like, you know, this is, here we have a stone. It is falling down, right? With the speed, with the distance, here is 50 meter actually, and the mass of the stone is 3 kilograms. And now they are saying that you will figure out the answer of it in terms of speed. When these type of questions are there, it's very easy for you to know that here the gravitational potential energy is completely converted into the kinetic energy. So you should use the law of conservation of momentum here. mgh is equals to half mv squared, right? So mv squared. So what we are going to figure out, you can cancel out this one. and V square will be equals to under root 2GH, right? Height is given to you. You can figure out the answer. 2 times 9.8 times its height, which is given to you here, and it's 50 meters. Okay. So when we will solve its answer is 31.3 meters per second, and you know that it is closer to the B option. So this is our best answer in it. Moving toward the next eighth question in it, they are saying that a coal fire power station generates electricity. Coal is burnt and the energy released is used to boil water. The steam from the water makes the generator move and this produces electricity. Which row gives the name of the energy stored in the coal and the energy stored of the moving generator? So you know that energy stored in the coal is actually chemical. So we have two options with us, A and B. But what about the energy stored in the generator, whether it's kinetic or whether it's hydroelectric? So energy stored in the generator will be what, students? Energy stored in the generator is kinetic or hydroelectric? It's B option, kinetic. Okay, because you know, generator is generating electricity, and that's why there will be a kinetic energy in it. Okay, and it is rotating, keep on rotating. So because of movement energy, motion, you know that kinetic energy is energy because of the motion of an object. So in generator, the turbine is keep on rotating, and that's why we are saying that it's the kinetic energy which is stored in it, and then it is then later on transferred into the electricity. Next question. A man puts some ice into a glass of water on a warm day, right? Some ice into a glass of water on a warm day. And after a short time, he notices that ice disappears. What does it mean? That ice melts. And that water droplets appear on outside of the glass, right? You know, sometime when we are taking the chilled Pepsi can, after some time, we will notice this thing that there are water droplets around its body. This is our normal observation, right? So they want that you will tell which two changes of state are taking place. It's very simple. One, here that ice is melting. Okay. And another, these droplets are because of the condensation. So B option it is correct because there are two changes of states are taking place, condensation and melting. Okay, question number 10 now. Gas of volume 200 centimeter cube is trapped inside a container by a piston. The piston is pushed to the right, like towards this. Its new position is, for example, this one. Or you can exactly say that it reduces to half of it, like this, because it reduces from 200 to 100. So actually, it is going to reduce half of it. The temperature of the gas is not changing here. Okay? It remains constant. So which row states the effect that this has on the kinetic energy of the gas particles and the force per unit area exerted by the particles colliding with the inside walls of the container? You know that temperature and kinetic energy, they are directly proportional to each other. If more temperature is there, then more kinetic energy is there. More kinetic energy means that the speed keeps on increasing. So if there is no change in the speed, then what happened that there is no change in the kinetic energy. Okay, and this is because that they are clearly telling us here that the temperature of the gas remains constant. So we will select the option from C and D. Okay, now as they have very less spaces, so force on a unit area increases and it doubles actually. It does not stays the same. Okay, so it doubles. So here we have, what is the option, correct option here for us? That is the C option. Okay. So I'm going to continue the rest of the questions in my next video. So please, you can watch those videos. Thank you so much. Take care. Allah Hafiz.